Hi, does everyone hear me okay? Okay. So I'm in Singleton. I'm going to be talking about GraphQL in Python. I'm at Singleton on Twitter and GitHub. If you have any questions afterwards or feedback, please tweet me. I love receiving feedback. Or email me ed@singleton.com. So, quick overview of my journey with GraphQL so you can get an idea of my biases, my level of experience, things like that going forwards. About 9 months ago, starting in December, I worked on a project between Boston Consulting Group Digital Ventures and De Beers, and that was a project called GemFair. And De Beers has a problem that in Sierra Leone they can't buy any diamonds because they might be blood diamonds from nearby countries which are having conflicts. And all diamonds in Sierra Leone are dug out of the ground by hand. There's no sort of mechanized systems. It's all artisanal mining. Now, if they could buy diamonds, that would massively increase the potential for miners to sell their diamonds for a high price because there's more competition in the market at the moment. They can only sell it to small, independent people who tend to rip them off. So De Beers wanted a system to trace diamonds coming out of the ground in Sierra Leone and track them all the way through. And then, obviously, this being 2018, they would go onto the blockchain at some point later on. That was a sister project that was developing the blockchain. And that's called Tracer, blockchain for diamonds. So we needed an app on the ground that could be used to sort of just track the progress of the diamond. And I was writing the back end that would sort of just receive all this data. Why did we pick GraphQL for this? I didn't. I was just writing the back end. I let the front end guy specify what he wanted to do because that was the core component, is what's out in the field. And I think realistically, it wasn't on his CV yet, and he wanted to, have another notch. I was fine with that. So what is GraphQL? I think of it as REST with a query language and with a schema. It really is basically the same as REST, but done differently. It's a specification for an API. It's also a set of tools around that. It gets more and more complicated as you add in more bits to GraphQL. I'm just talking about the core of GraphQL, but you can add in relay, things like that. There's more tools on top. I didn't get around to using those. So GraphQL doesn't use HTTP methods. It ignores them. And it's only the body of the request that it's interested in. Roughly, you've got queries and mutations, which are the equivalent of, say, get and post. One is intended to only be used for getting data, and the other one is intended for possibly making changes and getting data. Just like with REST, if you design your API badly, queries can make changes to the database. It's statically typed with a strict schema. This is sort of the equivalent of Hatios in REST and Swagger combined, but instead of being a discoverable API, you just got an entire definition of the API all up front, every type in it, every endpoint, the whole thing. There's a query language to specify what data you want to get out, rather than it being fixed by the creator of the API. Input and output types are separately defined. I'll talk more about this later. And queries can traverse object relationships. This is where the graph part of the name comes from. So you can select all the users, you can select all the users' friends, and all the users' friends, and things like this, all in just one single request. You can think of it as sort of like joins between tables in SQL. So, that really isn't very bright, is it?
Maybe turn the lights off?
That's a good idea, but I'm not near the light switch. That's a bit better. This is an example of a query. It's very similar feel to JSON, but different. It's similar enough that I keep accidentally writing JSON syntax, and it's different enough that that's almost always wrong. If you can see, it's an interesting thing that any attribute you're requesting can be passed parameters if it accepts parameters. So anything can be passed parameters. So for example, here we're saying we want the users and we want the height of the users in centimeters rather than in feet and inches, anything like that. That's a bit better. An example of a mutation. The only difference is just the word query or mutation. And with a mutation, you've got data that you're putting in, and then a query at the end that expresses the data you want to get out as a result of this, which doesn't have to have anything to do with the data you're putting in. You could put some data in and then ask for something completely different. Standard set of types, nothing too exciting. ID type is just a string that's just been marked up as not for human consumption. It's assumed to sort of be machine only. Apart from that, it's fairly standard. CQRS, command query responsibility segregation, is a really complicated way of saying what you put in doesn't have to be the same as what you get out. This is possible in GraphQL because there is a complete separation between the things you put in and the things you get out. Now, realistically, for a lot of situations, if you're just sort of got GraphQL as an API in front of storing data, they'll be the same. With a database table, whatever you put in, you're hoping it's going to be the same as what you then take out of it if you ask the same thing back. But it doesn't have to be that way. You can do things differently. A common use case is an event-based system where you're putting a stream of events into the system. They're having lots of effects, they're doing things, and then you ask for data out, and objects coming out, so events in, objects out. You don't have to do that with GraphQL, but it makes it very easy. Benefits, fewer round trips to the system. This is what front-end developers seem to get really excited about with it. Certainly the ones I've dealt with, this is one of the big things for them, that they can get all the data they need for a particular operation in a single request, rather than in a RESTful system. I'm quoting their complaints, this is not necessarily what I think, but the idea that you have to get, say, a list of all the users, and then you would pass in all the user IDs to get a list of all of their friends, or a list of lists of all of their friends, and then for each of those, it gets quite complicated. And they seem to really like the fact that you can just do a single request and get the data you want. Even if the data isn't in the right shape, they can still get all the data, munge the data around a bit, and then pass it on into the system. Having a schema, which, because it's a generated schema, is actually correct, unlike, say, documentation, which tends to sort of never quite align up with the API. Allows static analysis. Again, this is actually quite impressive from a front-end point of view, because the API that you're coding against, your editor can just contact the API, ask for its schema, and do code completion against the data structures, queries, and the code completion in GraphQL tools is really impressive. It's just built into everything that deals with GraphQL. Improves collaboration. I'll talk about that in a bit. It's driven by Facebook. Facebook are a big, powerful tech company. They're doing lots of interesting things. They're probably not going to drop it anytime soon, so there's going to be, they're putting a lot of money and effort into it. That's going to carry on for the foreseeable future, and it integrates well with a lot of their other tools like React. Drawbacks. It's driven by Facebook. They're not the most ethical company in the world. I'm not a fan of theirs. I don't even have a Facebook account, so it feels slightly wrong, but it's immature. It is definitely immature. So it's got great documentation, but all the documentation is sort of Facebook's documentation for it. There aren't many books about it. It hasn't been thought through in great detail. I mean, what they've done, they've thought about well, but lots of people have been thinking about REST for a long time. So there is some sort of immaturity there, but that will come. And another example of the immaturity is you don't have much choice of which libraries you use. There's one Python library, there's one JavaScript library, there's one Ruby library. There's no competition out there yet. It's all sort of fairly standard. Some things, because it's immature, some things haven't been specified necessarily. At the time that I was dealing with it, this might have changed, but how to do file uploads through GraphQL hadn't been specified. I was happy just to do multi-part form, which would have been straightforward, but my front-end developer was having problems with that, couldn't do it for some reason. So in the end, we had a REST API just for file uploads, and then GraphQL API for everything else. But again, these are things which will improve quite quickly over time, I imagine. The collaboration side of it, this is the reason why I would happily use it again. When you have that clean separation between a back-end developer and a front-end developer, it really empowers front-end guys because they can get the data they want. They're not relying on you to structure the data in each of your endpoints in the correct way. They can choose how they want the shape of it to come out. From my point of view, it felt like giving them controlled access to the database because I just sort of opened up, this is all the data I've got, and you can pull it out however you want, but because they're going through an API, they can't actually do anything. I'm still in full control, but they can choose how they get things out. And it massively reduces the number of cycles between those kind of request-response cycles between developers, where they go, oh, I just need this slight change, or I need it to be slightly different, I need this sort of. And so it became much more like they sort of said, okay, we want to be able to store and retrieve this data. I did it once, that's it. There was no sort of fixing, tweaking, that kind of cycle. So that was a huge benefit for me as a backend. It made my job slightly embarrassingly easy creating that because there was a lot less, whenever you're doing REST, there's a lot of meetings and thinking about how should the API look. With GraphQL, it almost didn't matter how it looked because they could just get the data, change it in a single request, change it, and do what they wanted. So, the Python side of GraphQL. There's a library called Graphene, and I find the name slightly annoying because whenever you search for graphene, you find the chemical and not the actual library, so you always have to sort of add the word Python into all your searches. It's a wrapper around multiple smaller libraries, so it's created in quite a modular way, which is a good way to do it. There's lots of sort of plugins. There's a plugin for SqlAlchemy, a plugin for Django, a plugin for Flask. The declarative types will be familiar to anyone who's done anything with any ORM. If you've used SqlAlchemy, if you've used Django ORM, if you've used any of the sort of validator or serializer libraries, it's really familiar. You'll see in a minute. Really well documented, very impressive effort. All of GraphQL is well documented, and Graphene itself is as well. In fact, most of the code samples I've stolen from there, not all of them, and I have tweaked them, so if you see any mistakes, that's not their fault, that's probably me introducing errors. So, there's two main types of objects in GraphQL. This is in Graphene and in GraphQL in other language implementations. There's objects and there's input objects. I found it much easier to think of this as output objects and input objects, but it isn't. They are just objects and input objects. This is an example of an output object. You literally just subclass the object type, declare attributes on it, and you can have calculated attributes. Any function that begins with resolve, underscore, and then an attribute name will be called to get the value of that attribute instead of sort of reading it from the system. Input objects are exactly the same, but it's just a different type. You don't have calculated attributes on input objects. And query objects are just an object exactly in the same way that objects are. They have attributes. You have a function, resolve that attribute, which can calculate a value, or it can go off to the database, get things returned. So that could be an attribute users, resolve users. You just, however you want to do it, you just go off and get data from any system you want and return it. It's that simple. The way that the schema knows that an object is a query is just, you tell it, these are my queries, these objects are queries, and then that's how it can follow down the graph, because if these return other objects, well, it knows how to resolve attributes on those and just cascade down. Reflecting from SqlAlchemy is really easy. You have yet another object type to subclass, and in your declarative types, instead of listing out all the attributes you want on that, you just say, go get them from this model instead. And it looks at the model, gets the attributes, and generates it, including looking at relationships and relationships to other types that you've defined, and it handles all of that, handles it very well. It doesn't, however, reflect input objects. So you've got to have, assuming you're using a database system, you're sort of putting the same data in, the same data out, you've got to specify all of these objects twice. So your user, you've got a user and an input user. And there was no way to introspect input users. So you saved yourself all this wonderful effort of introspecting the SqlAlchemy models for the output data, but then for the input data you just had to write them all out by hand. So I wrote quite a hacky bit of code that actually just goes and does the introspection. You pass it a model, and it will go and try and introspect an input object. At some point I need to get around to sort of contributing this back to Graphene SqlAlchemy plugin, and then it will be there. This is just another example of the immaturity of the project. It's one of those things that will come about through time, or in fact, I sort of half have here. And also, if anyone does actually go ahead and use Graphene SqlAlchemy, give me a shout. You can have this code. If you have custom types in SqlAlchemy, so UUID is well supported in SqlAlchemy, but that doesn't exist as a concept in GraphQL. Then you have these converter functions, which you just say, okay, if it's a UUID type, treat it as an ID type in GraphQL. And you just write one function and register it, and then it knows how to do that. Again, this is a bit tedious if you're using loads of custom types in SqlAlchemy, but you just do it once, and then they're there. This is another thing that could eventually be factored down. It should really more just be sort of saying this type, that type, this type, that type. It should just be a dictionary or something like that, rather than a function per type. So, implementing in Django. It's exactly the same. It's so exactly the same, I'd just be doing that whole sort of thing again. The only difference is, it being Django, you've got to install an app and register it in your settings as one of the installed apps. That's it. You do the same thing that you would do with the SqlAlchemy models, but you're using Django ORM instead. It works extremely well, and exactly the same in Flask. And the benefit with both Django and Flask is you've got the request there, so you don't have to manage sessions. I prefer not to use frameworks, I just sort of use libraries. So I was having to juggle sessions around there, but Django and Flask sort all that out for you. Conclusions. Improves relationship with front-end devs. This is a huge benefit. It's great. I loved using it. I loved the experience of doing code cycles with someone using GraphQL. It can be more efficient because you're doing fewer requests to the server. You can reduce load on the server. Also, we were working, well, our product was being deployed in an environment where there isn't cellular coverage across the whole country, and mines tend to be out in the countryside, not in the middle of the city. So quite often there would be no coverage, or there would be just enough coverage to get through, say, a 10K, 20K piece of data, but there was no way you could get a 100K picture through. They had to go into town and sync once they got into town. So being able to carefully structure the requests we want, just make one request and get back all the sort of data we needed for this in a single request was a huge benefit in that situation. It's probably not going away. It felt better than using REST. It's well supported. I imagine it's going to be around for a while. I don't think it's going to replace REST anytime soon, but it can be run side by side with REST. And particularly my experience with looking at it in Django, it seems really easy to run a REST API and a GraphQL API at the same time, just on two different endpoints. I think that will be fine. That's it. As I said, if you want to do any questions offline later, or you want help or ideas for this, do get in touch. And if there's any interest, I can knock up a minimal Django GraphQL app, and because I have the code that I can't share, but I can remove all the bits I can't share and just have like a minimal app, a minimal Flask app, whatever, if people are interested in that. So do get in touch.
I think we've probably got time for one question if anybody has any.
Did you have to do anything over access control over GraphQL? So if somebody should only see a particular subgraph or can't see some users?
Yeah, yes, I did. So the way I handled that, you can have, I had multiple APIs. So one API was for the client in Sierra Leone. There was another API which was for the backend, for the admin interface onto the data. But all of that is sort of in your own code, so you can just say this query can only be accessed by a certain type of person. That's very easy to handle. We used JWTs on top of it, and again in Django that would just seem to be sort of fairly plug-in. It was quite easy. Time for another question?
I think that's
Okay.
a approach. So
Thank you.
Please do them again. Thank you.